Bienvenidos, Ushabdi, and welcome to this Hut8 networking Techtorial on BGP's Remove Private AS feature. This is going to be the first in a two-part series, where in this video, we're going to be focusing on Remove Private AS. In the second Techtorial, we're going to be looking at the Remove Private AS All Replace AS and how that behaves. So here we're solely focused on Remove Private AS. So over the last 3.5 to 4 years, I've been focused solely in my day-to-day job on performing a multitude of migrations off of legacy AT&T and Verizon telco circuits, and these could be anything from a T1 to a T3 to an OC3 all the way up to an OC12, where we've been migrating away from AT&T and Verizon because we've brought everything in-house from a service provider perspective. And so now we're providing all of our own MPLS cloud services. We're providing all of our own internet access. And after doing a migration just this past week, I was doing a knowledge transfer with some of the junior members on the team, and I was explaining to them how we're getting internet access from a remote facility that we have, a disaster recovery facility that we have at a remote location, how we're getting internet access. And the question came up, well, how is that working? Because the in-house provider, they've given us a private autonomous system number. So how can we access the internet? Well, let's go ahead and dive in, and I'm going to explain to you exactly how that's being done. So let's first take a look at a high-level network diagram here of what we're talking about. And again, this is similar to how we're set up. It's not exactly how we're set up. And obviously, the autonomous system numbers that I'm using are all make-believe. But this is definitely going to drive home the point in this demonstration. So one of the things that's taking place, and we'll start over here on the far left-hand side, is that this is our disaster recovery facility here. And this is where we're getting our internet access through our in-house service provider. So again, this used to be here, router 2 and router 3, AS23, used to be AT&T. And it's a well-known fact that AT&T's autonomous system number, or the one that we were peering with, was 7018. So we have two connections, right? We have a primary path, which would be our northbound here, and we've got this southbound. And the only reason I'm using north and south is because it's top and bottom here. So the top connections are primary path, bottom connections are backup or our secondary path to the in-house provider. So we obviously want to control the outbound flow of traffic. And that's very easy for us to do. We have a single router here. We will always and only have a single router because it's our DR facility. So, and we're going to be setting all of this up, we're using Cisco's WEIGHT. Now, we could be WEIGHT. We could be using local pref, but it's a Cisco router. And again, there are no future plans to bring in a second router, so we'll use the WEIGHT attribute. Now, we're also wanting to make sure that when traffic returns from the internet and hits our service provider, that the provider brings the traffic back on the same path the traffic went out on. So the traffic is egressing out the northbound path. We want it to ingress via that northbound path as well. And so you can control with 100% certainty your egress or outbound flow of traffic, but you can only influence, in other words, make a best effort to try to influence the return or egress flow of traffic back into your network. Because remember, the definition of an autonomous system is something, an entity that is under the control of a single entity, right? So we control 65488. The in-house provider has full control over AS23. Now, one of the great things about working with an in-house provider is it's basically part of your own organization. So we know all of the individuals that are setting all of this stuff up. We have great relationships. We get to see all the configuration work. And so we can work with them to say, well, hey, maybe you guys could set the med or do something like that. But in this case, it's just as easy to do AS path prepending. Now, the question that came up when we were doing the knowledge transfer as to how this was configured was, well, that's a private autonomous system number. And you can see I've got the ranges up here for your public and your private ASs. And they said, that's a private autonomous system number. How are we, the in-house provider, how are they advertising our network out to the internet with an autonomous system number that's private? And the answer is they are not. They are doing remove private AS. So now this begs the question, why did they give us a private autonomous system number to begin with? So here's one use case where that is what would happen. PA versus PI. And these are terms that if you've ever taken the CCNP route curriculum, you've probably seen. And it's provider aggregatable address space as opposed to provider independent address space. So in the case where the in-house provider owns our IP addressing space, and they do all the way down to a /16, right? So it's a pretty big chunk of address space. They own the networks that we're advertising anyway. And in the case where it's provider aggregatable, in other words, the provider owns your address space, it's really convenient for the provider to simply give you a private autonomous system number. That's how they'll set the pairings up. And then when they're advertising the /16, the aggregate, because we have a whole bunch of /24s, I think it's about 6 or 7 /24s that we are advertising. When they advertise that aggregate out of the /16, they simply remove our private AS. And what router 4 is going to see is that our networks are showing up. Oops, sorry, not 24, I meant 23. Our networks are showing up as autonomous system 23. So they basically strip our autonomous system number, the private autonomous system number out, and all of our advertisements go out with their autonomous system. And that's okay because, again, they own our address space. So now let's go ahead and let's set all this up. I'm using Cisco's Virtual Internet Routing Lab, or VIRL, to do this. Now, the IBGP peering here, we're going to see it, but it's already set up, and the peerings between router 2 and 3 and 4, that's all done. Our focus is here on how we're going to handle this. And I'm just simply using, for simplicity, we're going to advertise the 1111/32 out, and we're going to see what that looks like with no remove private AS, and then what the provider would do, which is remove the private AS. And we're going to look at it from router 4's perspective, and we're going to see that we can still influence that return flow of traffic even though the private AS is being removed. And that was a point of confusion, was that one of the junior guys thought that we were going to do the remove private AS, and I was explaining, no. What happens is it's the provider, it's the provider who has the next hop to the commodity internet, or to I2 or whatever it's going to be, that is going to do that remove private AS. So let's jump into the command line here. So here I am, and this is router 1, which is our router, and you can see I've got the autonomous system number in there. So let's go ahead and go from user exec to privilege exec into global config, and I'm going to say router BGP 65488. All right, and so we'll keep the config simple initially. I'm just going to basically say neighbor 10.1.2.2, and so that's router 2. And the remote AS for router 2 is going to be 23. And then we're going to do the same thing for neighbor 10.1.3.3, and their remote AS is also 23. And so what we should see here after we set up router 2 and router 3 is that we're going to have some peerings established. Now, the NLRI, or the network layer reachability information, excuse me, that I'm going to be using is just simply network 1111, and it's a /32. All right, so we're set up here. Again, I'm going to come back for the AS path prepending in a second. Let's bring the BGP peerings up first. So here's router 2. So now router 2 is already configured. And if we do show run section router BGP, we can see that the BGP configuration is already done for the iBGP peering, which is to router 3, as well as the eBGP peering, which would be the quote-unquote internet, which is router 4. So if I were to say show IP BGP summary, we can see just how long those peerings have been up. And if I were to say show IP BGP, we would see what kind of network layer reachability information we have. And the important thing is we see right now that we've got 2 paths to reach router, or I should say to reach the 4444, which is router 4's loopback address. And right now, the preferred path is the eBGP path. So directly from router 2 to router 4. So let's go ahead and get into, we'll get into global config here. And I'm going to say router BGP 23. And let's set up our peering with router 1. So we're going to go ahead and say neighbor 10.1.2.1, and the remote AS is 65488. Now, the peering is not going to come up right away. If we take a look at the show run section router BGP, what you're going to see is that I'm using the no BGP default IPv4 unicast option in the BGP config. And so this means that I need to come down and activate the individual peerings. That way the peerings aren't establishing themselves auto-magically as soon as I enter the neighbor statement. So I want a little bit more control here. So we say address family IPv4, and then I'm going to run the same neighbor statement. It's going to be neighbor 10.1.2.1, activate. Now what we should see in a couple seconds here is that the BGP peering between router 1 and router 2, and there it is right there, is now up. So how do we confirm that? Do show IP BGP summary. And we should see that we have a new peering here, and we do. We see the autonomous system number of router 1, and we see that we've received a single prefix. So how would we check to see what we've received? I say show IP BGP. Do show IP BGP. And again, we know that that is the NLRI that we're interested in. And so you can see the autonomous system path number right there. So this originated in AS65488, and router 2 is seeing it. So that's great. So let's go over to router 3 now. So on router 3, we're going to pull the BGP config up, which is going to look conspicuously like, so we'll say show run section router BGP. It's going to look conspicuously like the config on router 2, right? And looks like we have an option in there that I wanted to strip out. So let's go ahead and put neighbor, we'll say router BGP 23, and then we're going to say neighbor 10.1.3.1, remote AS is 65488. All right. Now, before we activate it, I'm going to go down into address family IPv4, and I'm going to say no, and I want to get rid of that statement right there. And that was kind of hung over from when I was setting all this up initially. So now what we're going to say is neighbor, and let's activate that peering between router 1 and router 3. And 10.1.3.1, let me make sure that I type in the right command. Oh, I'm sorry. I actually typed in the wrong neighbor statement earlier. So let me back up here. We're going to say no. And we'll say Control-C, Control-V. And now let's try that again. So we'll say neighbor 10.1.3.1, and the remote AS is still going to be 65488. I just had the wrong IP in there. And now we want to go address family IPv4, where we're going to say neighbor 10.1.3.1, and we're going to activate that peering. We're going to see that the peering is going to come up here in a couple of seconds. And we'll say, when it does, we're going to say do show IP BGP summary. And we can confirm that. And we have received the loopback address for router 1. And we would know that when we say do show IP BGP. Now, you may be looking at this and saying, well, hey, wait a second. When you run this command here, right, or even when you say show IP BGP, what if you've got like 5,000 routes? How are you going to fish through and figure out what's coming from which AS or from which neighbor? And so the easy way to do that is you would have to set soft reconfiguration inbound. So let's do that here on router 3. So if I was to say 10.1.3.1, soft reconfiguration inbound. And let's go ahead and say do clear IP-BGP. And we'll put the star in, and then we'll say star out. We'll just do both to make sure. So now what I could say is if I wanted to know exactly which NLRI, or network layer reachability information, which is a fancy way of just saying, the routes that I'm getting. If I want to see what information specifically from that neighbor, router 1, that I'm receiving, I would say do show IP-BGP neighbors. Oh, no contextual help there. And then the IP address of the neighbor, 10.1.3.1, and you would say received routes. And so this is the routing information that I'm receiving before I'm doing any filtering or anything like that. And so that's one way to trim it down. The other way to trim it down would be to do a regular expression on 65488. But I prefer this. I think this is a lot easier. So there's the information. We know we're seeing it. And so let's look at router 2. What if I don't have soft reconfiguration configured? Here's what you would see. So I'd say do show IP-BGP neighbor 10.1.2.1 received routes. And you would see a message that tells you, hey, inbound soft reconfiguration's not enabled. And so it's easy to enable. And we just saw how to do that on router 3. And you would just simply say neighbor and then soft reconfiguration inbound. All right, so I think we're set up here to start talking about what router 4 is going to see. So on router 4, when I say show IP-BGP, you can see that router 4 does see the network, or the NLRI, of 1111 to the /32, and we can go from right to left when we read the autonomous system path. It originated in 65488, and then it came from the directly connected autonomous system number 23. Now, if this is an internet router, right, we have a problem here because we've got this private autonomous system number that is not going, we can't guarantee that it's globally unique. And that's why the private autonomous system numbers, just like the RFC 1918 IPs, those aren't allowed on the internet because you can't guarantee that they're going to be globally unique. They're for private use. So let's take a look back to our drawing here. And we're all set up, right? We've got the NLRI from router 1, the 1111 is showing up all the way over here. And actually, I just noticed that should be 4.4.4.4. So all the way over here in Autonomous System 4 and advertising out to the internet, but we've got the private AS. So there's two things we want to set up. The first thing we want to do is, from our perspective, we want to make sure that we are controlling with absolute certainty and predictability the outbound, the egress flow of traffic on router 1. And so here's how we're doing that. Again, the use case for wait, and this is a great use case for wait, is that in my configuration, or I should say in our configuration, I will only have a single edge router, ever. There's no plans for a second router because it's a disaster recovery facility. And if it's a Cisco router, there's no reason that I can't use wait. I would use local preference if I had multiple BGP edge routers that were communicating via IBGP. Because remember, wait is a locally significant attribute. So how do we do that? Well, let's go ahead and say do show run section router BGP. And so here's our BGP config right now. And so what I'm going to do is we're going to spice it up a little bit. I'm going to say no BGP default IPv4, and it's IPv4 unicast. And so now our configuration has been converted, do show run section router BGP. Now the interesting thing with VIRL that is different than the behavior I've noticed on Cisco iOS is you'll notice that VIRL did not create the address family stanza and activate the peerings that are already active. Regular BGP, or I should say regular iOS on physical Cisco routers does that. So here we need to say address family IPv4 unicast is the whole command. So you can just say address IPv4. And here's where I need to go ahead and get my neighbor statements in. 10.1.2.2 activate, and then neighbor 10.1.3.3 activate. So I need to make sure I keep those in there. So do we have our peering still? We'll say do show IP-BGP summary. And we do, and everything looks great. All right, so now the configuration is changed, and it looks like this. So I'm router 1. I have full control over router 1, and I'm going to control the egress flow of traffic. And so the easiest way to do that is to pick the neighbor whom we want to prefer for the outbound path and say neighbor 10.1.2.2, and I can simply set the weight to some value greater than 0. I'm a big believer in 9999, right? That's a value that I like to use for our preferred outbound path. So now I'm going to put that in there, but we're not done yet. What we want to make sure we do is say do clear IP-BGP star out, and then we'll say, I always do both, star in, just to be sure. Do a soft reconfiguration here, right? It doesn't tear the peering down, but it refreshes everything, and now the preferred path is going to be out through router 2. In fact, if I was to say do trace to 4444 and source that from my loopback 0 address, which is the 1111, we should jump to router 2. And you can see right there that we jumped to router 2 and then to router 4. Now, let's confirm that what I'm telling you is the truth. So what if I was to say neighbor 10.1.3.3 and set the weight there to 20,000? And then let's do a do clear IP. And actually, before we do that, let's quickly run that trace again and see what happens. So this is why I was saying you want to make sure that you do a quick refresh, because take a look at the path it's still choosing. It's still going to router 2 and then to router 4. And so that gives you the impression that, hey, wait a second, you told me that the weight is going to control that, and we've got absolute control. And it does, but we want to do our refreshes. So we want to say do clear IP-BGP star out, and I always do star in. I do both directions just to be paranoid, to be 100% certain. So now let's rerun that trace command. Aha! And now we see it goes to router 3. But again, we're interested in having all of that traffic go to router 2. So I'm going to say no neighbor wait. We're going to do a clear in. We're going to do a clear out. And we're going to trace it one last time just to make sure. And there we go. We're using that egress path direct to router 2. So that's how I'm controlling, because again, remember, I'm originating this in LRI. I have 100% control over it. On the egress. On the ingress, it's a different story. Because if we refer to the diagram, what if here the provider said, well, you know what? We want traffic to egress our autonomous system out router 3 toward you, and we're going to set the local preference. There is nothing I could do at that point because they are in control of that entity, of that autonomous system. They have administrative control. So again, you can try to influence, but you cannot control the return flow of traffic from an autonomous system that you do not administer. So again, this is all being done in-house. We work with these guys on a daily basis, so it's very clear that we talk to them and say, hey, we're going to do AS path prepending. Can you make sure that you're not doing anything? And they're like, yeah, no, we're not doing anything at all. So let's go ahead and set up the AS path prepending. And here's an easy way to do that. We're only dealing with a single route right now. That's a 1111/32, right? So this will be very simple, but you would just expand this prefix list, and the route map would look the same, and the application of it would be the same, even if you had 5 different prefixes or 50 different prefixes. So here's what we're going to do. We're going to create a prefix list. I'm going to say IP prefix list, and we'll just call it NLRI, and I'll say sequence 5 and permit 1111/32. And what this is doing is it's going to match that route, the 1111. And that's all I need. Again, if you had more, and let's do something here a little. So we'll do this. I'll say 10 permit, and maybe you're advertising, 140.45.67.0/24, right? If you wanted to make sure that you're prepending your autonomous system number to these prefixes in the BGP updates that are getting advertised to the neighbors, right? And so again, we don't have that network. And you know what? I'll spin up a loopback address. We'll keep it interesting here. So let's go ahead and say interface loopback 140. IP address is going to be 140. What did I say? 45.67, and we'll say 1 because we're router 1. We'll make it a /24. 255.0. I'm going to advertise that in BGP as well. So we've got this loopback address now that looks like an internet route. So let's go back into router BGP 65488 and address family IPv4, and let's say network 140.45.67.0, and our mask is a 24. And there we go. All right, so we've got our prefix list. So let's turn our focus back to this AS path prepending. We've created our prefix list here, right? That matches the NLRI that we are advertising to our provider or to our internal provider. So now what I want to do is I want to create a route map. So I'm going to say route map, and we'll just call it NLRI. And if I don't say anything here, the default is permit 10. So I could have said route map NLRI and hit enter. And that is what it actually would be, is route map NLRI permit 10. And so here's what we're going to do. We're going to say match IP address prefix list. Very important that you put prefix list there because we're not using an ACL. We're using a prefix list. And then I say NLRI, right? And the last thing I might do would be to say route map to allow everything else to come through, but not be prepended would be route map NLRI, and then we'll say permit 20. All right. So there we go. So I've got my prefix list. I've got the route map that refers to the prefix list. So let's go ahead and apply this. Now, where do I want to do the prepending? And this also caused some confusion when I was explaining to some of the junior guys on the team, because they initially said, oh, perfect. Yeah, no, we're going to prepend here to router 2. And the answer is no. Remember, BGP is going to prefer the shorter autonomous system path number, not the longer AS path. It's going to be the shorter AS path. So we want to do the prepending, and in fact, let me move this here. We want to do the prepending here. Make that look a little nicer there. We want to prepend going to router 3, right? We're going to do the AS path prepending to router 3, which means when we have a BGP update that goes to router 3 for the 1111 and the 140, whatever I came up with, 4567 or whatever, when that is advertised in the BGP update to router 3, it's going to be showing up with 5 instances of our autonomous system path. And so here's how we would do that. And it's actually pretty simple. Now we want to do the AS path prepending, so I'm going to go back into my route map. And I could have done this originally, but we're going to go back into the route map. I'm going to say permit 10, and we've already got the match statement in there. Now I'm going to say set AS path prepend 6, and what is our AS number? 65488, 65488, and we're going to do it 4 times. So that way, 488. There we go. So now let's take a look at the route map. Do show route map in LRI. And I apologize, I didn't put that in there initially because I wanted to talk about it. But you can see here, the permit sequence 10, it's going to match the prefix list, so the NLRI that we've matched in the prefix list, and then it's going to prepend that amount of autonomous system numbers, these 4 ASs, and always prepend your autonomous system number. Do not prepend somebody else's AS number. And so when router 3 gets the BGP update, it's going to say, okay, well, this has got an AS path of 5, and he's going to learn from router 2 that 2 has a better path, and that's going to be the preferred path. So let's go ahead and apply this route map now. So I would say router BGP 65488, and then we're going to go to address family IPv4, and I'm going to say neighbor. Remember, 10.1.3.3 is router 3, and we're going to say route map in LRI. Now, is it in the inbound direction or the outbound direction that I want this to be applied? Exactly. It's going to be in the outbound direction. So again, I always do a do clear IP BGP star in, even though I've only made a change outbound. I want to refresh everything, right? So I clear in and I clear out. So Let's go over to router 3 and see what router 3 sees now. So there's a couple ways we could do this. I could say show IP-BGP, again, because we've got a limited number of NLRI that we're looking at, and take a look at what we've got here. So router 3 now sees 5 occurrences, right? The original occurrence, which is my autonomous system number, and then the 4 instances of my autonomous system number that I have prepended to the autonomous system path. And so router 3 is looking at this and it's going to say, yeah, no, to get to the 140.45.67, I'm definitely going to go to my IBGP peer, router 2, because the AS path, take a look at that. It's pretty demonstrative there, right? That the shorter autonomous system path is definitely going to go to router 2. So is this going to be everything we need? And the answer is no, it's not. But let's come over to router 4, excuse me, and let's see what router 4 sees. So I say show IP-BGP, right? And we can see that router 4 sees the best path is through router 2. All right, so we're good to go here. So what if I was to trace? If I was to say trace over to the 140.90, I'm sorry, not 90, 140.45.67.1, and I'm going to source that from my loopback 0 address, you can see that we jump to router 2, and then we go to router 1. So everything's working great. All right, so now we still have this issue here that our autonomous system path, when it hits the internet, has that private autonomous system number. So how do we get rid of that? Well, that's where we come back and we say we're going to remove the private AS. So if I was to copy this, and let's actually make it a little more representative, I think this is going to look a little nicer here in terms of the story that's being told, is that we're going to do it on both router 2 and router 3. I don't want to give the impression that it's one or the other. It's on both router 2 and router 3, where we just simply add in the remove private AS statement. So let's jump on to router 2 first. And we'll go from user exec to privilege exec into global config. We'll say router BGP 23, address family IPv4. Now, it's on the neighbor statement to the internet service provider, right? So not our in-house provider, but to who would be, you know, the commodity internet, whatever. So we're going to say neighbor 10.2.4.4, and we're going to say remove private AS. Now, in the second video, I'm going to be talking about the all option, but right now we're just going to remove the private AS. And we'll do a do clear IP-BGP star in and out. And we'll come over to router 3 and we'll do the same thing. We'll go into global config, router BGP 23, and address family IPv4, and we're going to say neighbor 10.3.4.4, remove private AS. Let's refresh our BGP tables. Oops, oh, did not want to do that. So that can happen if you forget to type in or out, right? Fortuitous failure. I just tore down the BGP peerings. If this was in production, this might be an issue. This could be what Brian McGahan refers to as a, what is it? I'm trying to remember, a career changing, I forgot, I'm sorry. It'll come to me though. A resume generating event. That's what it is. So Brian McGahan's the first person I heard refer to this as a resume generating event, is what that may turn out to be. All right. So we're back up though. We've got it set because we're in a lab. It's not a big deal. So now let's come out to the internet and say show IP-BGP. And what do we see? The private autonomous system number has been removed. And that was exactly what we thought was going to happen. And you can still see that our best path here from router 4 is going to be through router 2 to get to the 1111 and through router 2 to get to the 140.45. Now, a couple things I want to talk about here, and we can add to the conversation. Remember I said we work with the guys here, right, in Autonomous System 23, the in-house provider. But these guys out here in Autonomous System 4, they may not want to deal with us. They may not understand that we want traffic coming back through router 2. So what if over here on router 4, and let me go ahead and I'll just put in, and actually I'll change this here. Won't change it, but we'll change it. So we'll say it's, Evil Corp, right? And Evil Corp has decided that they don't care about our policy or our in-house provider's policy, that Evil Corp is simply going to route traffic the way they want. And what they're going to do is they're going to set the wait attribute. And before I do this, if I say do trace to the 1111, so let's see what it looks like before I make the change and source it from our loopback 0 address. You can see that we go to router 2 for the 1111 and to the 140.45.67.1, source it from our loopback 0. Sorry about that. We got the do. You can see we go to router 2, right? So right now, everything's working the way we want it to. But what if Evil Corp decides that they're going to be, well, evil? And let's get into their router BGP configuration where, and let's say do show run, pipe into section router BGP. And we'll take a look at their configuration. We'll go into address family IPv4, and they decide that on the neighbor statement to router 3, that they're going to wait that because they want all traffic leaving their autonomous system where they have full control to go to router 3. So let's do a quick refresh here. Do clear IP-BGP star, and let's remember the in and the out, right? And now let's take a look at what those trace route commands look like. So if we trace to the 1111, what's the first hop going to be now coming back through Autonomous System 4? Yeah, you can see that now it goes to router 3, but remember, internally in AS23, the best path is through router 2 because of the AS path prepending. So even if Evil Corp decides to be evil and send all traffic back through, we're looking worst case in this scenario at one additional hop, and then we make it to where we're supposed to be. What about that 140.45? Let's take a look at that as well. And we get the same result. Again, because remember, Autonomous System 4 doesn't care how we want the traffic to come back through our in-house provider, right? All they care about is that everything goes back through the southbound link on router 3. All right, so we have explained, and let's recap real quickly here. You're connected to a service provider using their own, the IP space they own, provider aggregatable space. We want to control the outbound flow of traffic. We want to influence the inbound flow of traffic. To control the outbound, we used wait. You could have used local preference, but we have a single Cisco router, so we can get away with wait. We want to influence the inbound or return flow of traffic, so we did AS path prepending. And even when we're doing the AS path prepending, it's still valid in this autonomous system, right? The provider here, before it gets stripped out and sent out to the internet. So when the traffic returns in AS23, the best path, because of that AS path prepending, is going to be through router 2. And that is how remove private AS works. And this is in a typical internet service provider use case scenario where they own your addressing and you're connected to them. This is how you could get internet access. And they just simply strip off or remove your private autonomous system number. All right, well, that is going to wrap up this Hut8 networking Techtorial on BGP's remove private AS. The companion to this is going to be the remove private AS all, replace AS, when we see what happens when you have a public autonomous system number somewhere in that autonomous system path with private autonomous system numbers as well. All right, thanks for watching. I hope this has helped you out, and I hope it's cleared up how remove private AS works. Thanks for watching. Have a great weekend.